How are the projects coming? How did the dry run go? Good? You pass all the tests? You know how to use Docker now? It's a good job skill, right? Everybody uses Docker nowadays. So, we're looking out for you by making you use Docker. Do you have any concerns about the project or anything that you're wondering about? Yeah, I believe so. So what will happen? You'll provide us with access to your projects, to your Docker containers. We will run the question generation component for each of your systems, and we'll get a list of questions. Then we will ask each of you to rate a certain number of those questions on the criteria that are set up in the project description. You'll score them. Other people's questions. Hopefully none of your own questions. If all goes well, none of your own questions will be included. You'll be scoring other people's questions. And then we will take from those questions a sample, and we will submit them to all of the question answering systems, and thus generating pairs of questions and answers for particular documents. Then again, you will get answers, and you'll have to rate those answers based on a set of criteria, like correctness, conciseness, fluency, and so on. And then based on those scores, we'll have a winner. In effect, there's a winner for both question generation and question answering, but we'll aggregate the scores so we have overall winners. And those will be announced after everything is done. In this case, it will be after the final. We like to do it so we can announce the result on the day of the final. But because we're doing the final earlier as the in-class final, then we can't do that because we don't have enough time to run all of the systems, get all of your judgments, run all of the question answering systems, get your judgments on them, in time to generate, to figure out who won and what the scoring is for each of those before the final. So any questions about that process? How do you feel about it? Who's feeling confident? Like they have the best question generation or question answering system that 11, 411, 611 has ever seen? No? Who's still struggling, to finish implementing everything that they've planned to implement? So that's the normal case. But you have over a week, so everything could change in that time. Oh, less than a week. That's right. You have one day less than a week. I was thinking it was Monday somehow, but it's Tuesday. So you have a week.
Well, a week is like 3 hours.
A week and 3 hours. So it is over a week.
Oh, you're right.
Get coding. I know you have other things to do as well, but this is clearly the most important. So do it. And today we're going to talk about NLP for languages other than English. So for most of this course, we talk about NLP as if it's about English, as if language equals English. That's convenient. Why do we do that, do you think? Yes. Because it's a common language that's shared hopefully by everybody in this room. Everybody speaks English. What are other reasons that we might do this? Yes.
Because our keyboards have Roman letters.
Well, they don't. You could have a keyboard that doesn't have Roman letters on it,
But most of
but you could as well do my favorite language, Hmong. It's written purely with Roman letters, but we've used almost no Hmong examples um, in this class, unlike any other class that I teach. Yes. So English is a global language. It's the language of international communication right now. It hasn't always been that way, and it won't always be that way. But right now, English is on top. So, so what does that mean about natural language processing and language technologies? Yeah.
If we're learning principles and techniques for English, they'll be probably applicable to what we would likely be doing in industry or down the line.
So one would hope that they would be broadly applicable, that you could learn these techniques for English and then apply them to English in other domains or to other languages. Well, as we'll learn today, it turns out that it's not quite that simple. So a lot of assumptions that you can make for English are not necessarily true for languages that are not English. And there are techniques that work pretty well on English that are difficult to adapt to other languages. And it really does matter what language you're modeling when it comes to designing the model. So we live in a multilingual world. English may be the language of international communication. It's the language with the largest number of second language speakers. But English isn't all there is. It isn't even the language with the largest number of native speakers. What is the language with the largest number of native speakers? Yeah? So Mandarin Chinese is generally considered to have the largest number of native speakers, and Spanish has more native speakers, I believe, than English. So English is so right there. If we're going to develop language technologies that can reach everyone, we really need to reach at least speakers of Mandarin and speakers of Spanish, in addition to speakers of English. But these are not the only languages. There are a lot of languages in the world, and some of these languages have lots and lots of speakers. So according to Ethnologue is a resource about the languages of the world, where they try to catalog all of the languages that are spoken in the world right now. And they list over 7,400 languages. Now they use particular criteria. They have particular criteria for deciding what they consider to be a language. And they use the number of cognates in a vocabulary list to decide whether two language varieties are dialects of the same language or whether they're separate languages. And also, sometimes the criteria that are used to make these decisions are not completely explicit. And linguists will fight about where exactly these boundaries lie. But we'll talk about this a little bit later in the lecture. The issue of language versus dialect and how you define the boundaries between languages. So here's a map of languages in the world. Which may not work anymore. Okay. So each of those green dots represents a language. And now you notice that some places don't have a lot of dots. And some places are very dense with dots. Can you see this? Yeah. Okay. But there are a lot of those green dots. And this means that not only do people speak a lot of different languages, but the typical person actually speaks more than one language. So if you're an American, you kind of think, oh, multilingualism is sort of an exceptional case. That's something weird. If you speak more than one language, you must be really smart or really weird. But in fact, throughout the world, and in fact, throughout the history of the world, most people speak multiple languages. That's just normal. So here is actually a pretty common situation of multilingualism. This is based on a language that I did field work on. It's spoken in northeast India in the state of Manipur, near the border with Burma or Myanmar. So in just one village, there's a language spoken called Gajai. And people in this village, when they're talking to people from neighboring villages, will use a language called Tongkul, which is related to Gajai, but it's different in the same way that Spanish is different from Portuguese. So this is a local language that's used just in that corner of Manipur. There's also a regional language that's one of the official languages of the state of Manipur, although it's not an official language of India, called Meitei or Manipuri. So pretty much everyone so like primary school in this village would be in Tongkul, but secondary school would be in English or in Meitei, Manipuri. Then everybody, to some degree, would speak Hindi, which is one of the national languages of India. And people in this area have contact with the government of India primarily through soldiers and other military and governmental people who are stationed there, because it's actually there's a long-standing insurgency where these people don't really want to be part of India, and so they've been fighting for the past, since the 1950s, 1940s, to be independent. And so there are soldiers stationed there, and in order to talk to them, you have to speak Hindi pretty much. And then there's a global language that lots of people in this area speak, which is English. So this is a language of higher education. It's a lot of these people that in Gajai village are Christians and have connections they're American Baptists, actually. And so they have connections to the US, and in those connections, then they use English. So it's very typical for somebody from Gajai village to speak 5 different languages. Does anybody here live in a very multilingual setting or grow up in a setting where they, what languages?
So I lived in Shanghai.
Uh-huh.
And, I thought Shanghai is silent, but apparently the quiz history told me otherwise. When I went to elementary school, the teacher would speak Mandarin to me if they're pleased with me and I'm being well behaved. Whenever they're mad at me, they would start to scold me in Chinese.
Uh-huh.
and that's why I like immediately like pay high attention to people and like become not scared when people start speaking Chinese because when I was a child.
Is always associated with you being bad. Yeah. Yeah, so we've got Mandarin, Chinese, and now English. Anything else?
I learned Spanish in high school.
Spanish? Yeah. Who else has a...
Yeah, so in school, I was taught English, Hindi, and Sanskrit.
Uh-huh.
And apart from that, I lived in central India.
Uh-huh.
So there were a lot of Sindhi speaking people over there.
Uh-huh.
So I know a bit of Sindhi and Marathi.
Uh-huh.
So they were the five languages.
Yeah. I mean, that's not exceptional. That's kind of the normal, like, a modern nation state, then we get the sense that everybody in a particular nation speaks a language, but that's never been the case historically, except in a few situations. Yeah.
Just one question. You mentioned Kachar as a village language.
Hmm.
But shouldn't we consider it a dialect instead of a language?
We'll get to that question. I'm using these terms as linguists use them. And in the linguistic usage, then a dialect is a variety of a language that's mutually intelligible with other varieties of the language. That means that if you have two language varieties and the speakers of those language varieties can understand one another, then those are dialects of the same language. And every language variety is a dialect of some language.
But as far as I know, a speaker of Kachai
Uh-huh.
Kachai can be understood by at least speakers of Tangkhul.
No. A speaker of Gajai cannot be understood by a speaker of Tangkhul any more than a speaker of German can be understood by a speaker of Dutch. They're quite different. They differ in their sound system. They differ in the structure of words. They differ some in the structure of sentences. So it's like it's not like Hindi and Urdu. It's more like Hindi and Marathi. It's just that area happens to be highly linguistically diverse. So people have lived for a long time in very kind of isolated communities that used to be constantly at war with one another. They engaged in headhunting raids up until the British colonial period. And they would, they were constantly at war, always raiding one another, village to village for heads. And so there was limited contact between people in the different villages, even though they come from a common ancestry. And so the languages became highly differentiated, the language varieties. And what were originally dialects have branched off to become separate languages in the way that a linguist would describe the term. So if you have two language varieties that are not mutually intelligible, then they are dialects of different languages by the linguistic terminology, the terminology that's used by linguists. And we'll talk more about that in a minute. Oops. So, what do we want language technologies for? What language technologies do you use day to day in your lives, or would you like to use? And what language technologies would we want to see in languages other than English, Spanish, and Mandarin Chinese? Well, one thing, we probably want to be able to type or to enter languages electronically, into, so that we can text our friends and do that sort of thing. And along with that, we probably want some kind of autocomplete function. So if we're entering text on a phone, we want to be able to have a prediction about what we're going to type next. Some kind of spell checking or validation of orthography. Probably want speech recognition, speech synthesis. So this, in a way, is easier than this. Information retrieval. So you want to be able to use search engines and things like that in the language. It might be nice to have some kind of grammar checking. Machine translation, and question answering. And this sort of goes along with information retrieval, right? So you want to be able to ask questions in the language and get answers. So these are examples of language technologies that people use in their daily lives. Can you think of any others? Yes?
So I know that Facebook had some trouble a while back because it didn't have enough, like, there was just going to have the flags, like posts that might be inappropriate,
Uh-huh.
graphic or against the rules. They had algorithms to do it, but it didn't work with a lot of languages that weren't English.
Uh-huh.
Like, it wasn't good at telling whether something was like an inappropriate, not even just like it's an inappropriate word, like it wasn't good at telling if things were, if they had like graphic stuff written in that language, or if it was like a perfectly innocent thing that they accidentally tagged as graphic. So
Right.
it's not necessarily like a daily personal issue, but I guess if you use Facebook every day, you want something like that.
So that's more this slide here. Language technologies for commercial, governmental, and research use. But that's definitely a case where multilingual language technologies really matter. If you're trying to do content moderation on an international platform, then you better be able to handle languages other than English.
I think the main problem is that they weren't flagging content that was being used to incite violence against, like, I want to say it was the Rohingya.
Yeah, that's what I heard too. So it's in Burmese. And Burmese is a low resource language, Myanmar language, the Myanmar language or Burmese. And so there are not a lot of resources for it. And so Facebook was not able to extend their content moderation reach to posts written in Myanmar to Burmese. And so people, were free to organize slaughter of the Rohingya on Facebook and over WhatsApp, although they wouldn't have control over what was communicated by WhatsApp anyway. But yeah. So there are different things that you want language technologies to be able to do that aren't necessarily geared towards end users, but are geared upstream towards things that companies or governments or researchers might use, like language detection. Usually you don't, you probably don't run a language detector to see what a document is. But if you use a web browser, you probably use language detection all the time. And if you use a search engine, you almost certainly use language detection all the time, but it's behind the scenes, right? Part of speech tagging. Again, people generally don't run part of speech taggers as end users, but there are a lot of applications that use part of speech tagging. Parsing, semantic role labeling, NER, summarization, translation. So summarization That might actually be an end user thing sometimes. Um, information extraction and question answering. And in order to make all of this work, you need certain infrastructure in place. And here are some of the things that you need. You need a character encoding. So Unicode has gone a long way to solving this problem. There was an old time in my youth when every language had its own character encoding, right? And for Chinese, there were two rival character encodings. There was GB and Big Five. And GB was for simplified Chinese on the mainland, and Big Five was for traditional Chinese in Taiwan, and also used in Hong Kong and parts of other Chinese-speaking places. So you had to do all of this magic to convert things from Big Five to GB or GB to Big Five, and it was a big mess. And if you were trying to encode a new orthography that didn't have a standard encoding, you would just come up with something, and then you had a big problem if you wanted to mix languages, like mix that orthography, because you might use 8-bit encoding for that language, and then you want to mix it with a 16-bit encoding for Latin script or whatever, and you have these overlapping characters, and it was a big mess. So Unicode came along and solved much of this, and most of the language's scripts are now encoded in Unicode, now have a standard representation in Unicode. So thanks be to the gods, we now have a solution to this problem, but there are still minor languages that are not in Unicode yet. And there are people who are hard at work doing this. But their efforts are hampered by the fact that Unicode meetings are now taken up largely by what? Yes? Emoji. Yeah, so this is a big frustration for the people who've been working on Unicode for a long period of time, because now they have to spend all of this effort deciding what emojis go in and what emojis stay out, instead of like encoding new languages. So once you have an encoding, you need a way of displaying the characters. So you need appropriate fonts and rendering technologies. You need input methods. You need also a reasonably standard orthography or spelling system. And this is something that a lot of languages don't have. So there's a language that I worked on as part of a DARPA project called Oromo. Oromo is a language spoken in Ethiopia. It's actually the language with the largest number of speakers in Ethiopia. It's a pretty big language, but it didn't have an orthography until the 1970s, or it didn't really have its own orthography, its own writing system. And they chose to use Latin characters like English. But it was not a language of instruction or an official language in any capacity, and no one really created a standard for how you write it. So everybody just sort of writes it as they pronounce it, or as they think they pronounce it, and so there are a whole bunch of distinctions that are just random, like the length of vowels. Some people will write the vowel of a word long, some people will write it short. So this produces some problems when it comes to language technologies. Why would you want a standard orthography if you're doing NLP? Yes? Uh-huh. Sure, that's true. What about if you think about training a language model without a standard orthography? So the same word may be written 3 different ways or 4 different ways. Yeah. Uh-huh. Right, right. You're going to have a much less effective language model. And the same goes for a lot of other NLP technologies. So another big thing is you need to have enough speech or text to train models. And the situation here has got better for a lot of languages in the past, 10 years, because there's more use of other languages on the internet, and you can go and harvest data, at least raw text. But this doesn't mean that for applications where you need parallel text, like machine translation, that the situation is good. It's actually pretty difficult. So as we go back through these things, how many of these would be worthwhile to have in languages other than English? Or Spanish or Mandarin? Well, that's the question. How many of these, do you, which of these would be a waste of time? Yes. So all of them, if you want to support other languages, do you think people should be allowed to interact with computers in other languages, then you really need all of these. So which languages have these sorts of things? Which languages have significant language technologies? These are the languages listed by the number of first language speakers. We've got Mandarin here at the top, then Spanish, then English, then Hindi, Arabic, Portuguese, then Bengali is all the way up here, even though, well, we'll talk about that. Russian, Japanese, Punjabi, German, Javanese. I bet some of you had never heard of Javanese, but it's one of the biggest languages in the world, spoken in Indonesia. And so on. Which of these have significant language technologies, do you think? So English and Mandarin do. So Japanese is pretty good, yeah? Spanish is pretty good. You know, Hindi is not as good as you would think, based on the fact that it's number 4 and it's in a technologically very important country. But Hindi language technologies are getting better. You know, there's now Alexa, but it's still not as good as you might expect. Yes?
Russian should be pretty good.
So Russian is good because Russians have spent a long time like developing language technologies for Russian, dating back to the Cold War era. So Russian, despite the fact that it doesn't have as many speakers as like Hindi or Arabic or Portuguese, it's still pretty good. Yeah.
German also has a lot of like linguistic that impact, so it's not pretty neat to develop language technology there and stuff.
Yeah, so German is pretty good. There's a lot of EU money that's gone into European languages, and a lot of that has gone to German. And so German has good language technologies. Not as good as English, but good. Yes.
Alan Black said that Korean was a really good language for NLP at one point too. And
Yeah.
I think that's like there are a bunch of rules and people actually follow them, unlike English.
Yeah, Korean, it's a very nice language. But Korean language technologies are actually pretty advanced. And there's been a lot of investment in these, partly due to the fact that South Korea is a very wealthy country, and uh, people just invested a lot in research and resources for NLP in Korean. So it's pretty good. Yeah. French is okay. So here's a kind of impressionistic view of how to what degree these languages are supported in terms of language technologies that we just talked about. Vietnamese it's not bad, but not great. Malay and Indonesian are okay, but Hindi, despite being number 4, is not that great. Bengali is pretty terrible, and so is Punjabi. These are languages of India. So is Telugu, so is Marathi, so is Tamil. Why are the Indian languages so poorly supported by NLP technologies? Yes.
Because in case of if I talk about Hindi, there are more vowels and there are more consonants as compared to English. So Hindi is like 13 vowels and
Uh-huh.
I have to count more consonants.
Um,
So there are a lot of rules in Hindi and as to be formalized in
but there are a lot of rules in English too, and I don't think that it has to do with Hindi being intrinsically harder. I mean, Hindi is different in a lot of ways from Telugu or Tamil, although it's related, more closely to Marathi and Bengali and even Punjabi. But there's some reason beyond just the structure of the languages why there's less support here. Yeah.
Is it that in countries with a high GDP per capita, there's kind of more of an incentive for companies to like make technologies to understand language because they're going to be more consumers of it?
I think you're right that this has to do with markets. So, per capita GDP in India is not as high as per capita GDP in some other countries, because although there's an educated elite, there are also a lot of people who are poor, who are not consuming language technologies. But I think that there's something else. Sophie?
I don't know much about or anything about the language, but I would say from the slides earlier, everybody, if there's like one national language that probably more likely for resources, which is one that most people know, this is one that's more you go like the reason why English probably like the US has a lot of teachers in a lot of different languages, but the government is probably going to focus and the companies that work there are going to focus on English because most people know it. So if there's one language that's more like institutionalized and that more people know in India, then that's more likely to focus.
Yeah, I think that there's something to be said for that. What language do people in India interact with computers in? In what? English. English. So what language is best supported for NLP? So if everybody is using language technologies in English. If the class of people who are using computers regularly um, are using English, then what incentive is there to develop language technologies for Bengali, Punjabi, Telugu, Marathi, or Tamil? Yes.
Is it the same reason why like Google has done
Yeah. Well, Google also has no language technologies because it has no separate orthography. Nobody can agree how to write Google. So, and everybody just assumes that you can use the Chinese is Chinese. You can use um, standard Chinese language technologies for Shanghainese or other Wu dialects, and you're just fine. Yeah, so Wu is one of the Chinese languages, of which Shanghainese is a dialect. So, do we care whether there are language technologies for Bengali, Punjabi, Telugu, Marathi, and Tamil? Is there any value in having language technologies for these languages? What do you think? Well, technically, yes.
These languages are the regional languages and they are not spoken across the country. They are spoken in a particular part of the country. And they're not mainly Bengali or Punjab. They're not mainly Bengali Tamil Telugu. As many speakers as compared to Hindi. All India.
Well, that's true that there are not as many, but there's still a huge number of speakers of those languages, more than there are of most national languages. So there are far more speakers of Bengali than there are of Russian, Japanese, um, Indonesian, Vietnamese, Korean, or French. So it's not like this is a small part of the linguistic population that you're cutting off here. Yeah.
I mean, it would be good if people all over the world had equal access to technology, right?
Uh-huh.
So if people from Java would be able to have a certain network in Java, that would be good. I mean, yeah, it may be a smaller market, but
Uh-huh.
it's still be useful to have.
Well, one thing that can happen, as you have penetration of technologies like smartphones into populations where people are not necessarily literate in an international language or are not as familiar with even national languages, it can be the case that people start to demand and there starts to be a market for language technologies in these languages, in the languages that are spoken in those areas. So there are kind of two different arguments that you can make. One is the economic argument. There are a large number of people who speak languages that are underserved. These are potential markets. We can make money off of these people if we will create language technologies for them. So that's the self-interested, market-based rationale. The other is a humanitarian rationale, and grounded in the idea that everybody deserves access to the good things in life in their own language. That they deserve access to language technologies, and to technology generally, in their language, and that it's a good thing to provide this access. And it so happens that those two things, in some cases, coincide, or intersect, I should say. But really, isn't everybody just going to learn English anyway? Why worry about these other languages? We can serve everybody in their first language as long as that language is English.
A long time ago, like some of the music French and like Portuguese and like what global superpower and
Right. So it will.
50 years English isn't
Right. It will be Mandarin. Right.
like
So. Esperanto. Yeah. So is it okay for language technologies to only exist for the main global languages? Well, even for many of these languages that we talked about, these top 20 languages, language technologies do not exist. But why do we need language technologies in other languages? Why aren't the top 12 enough? Why aren't Mandarin, English, French, Arabic, or Spanish enough? Why isn't English enough? Yeah.
I mean, the distribution is also going to change. Like Africa is going to have 5 billion people that are living on the continent in the future, and people are getting more and more smartphones. They're going to be more immersed into technology and having to be used for them.
Right. So big African languages are going to become more important in this regard. There'll be more people using smartphones in Swahili, or Chichewa, or Yoruba, or Hausa, or Igbo, and they're going to want technologies. They're going to be a potential market. They're also going to be needing language technologies. And so I would argue, you don't have to believe me, but I would argue that English is not enough. And the top 4 are also not enough. We need to think about language technologies even in languages that are relatively poor in resources. So let's talk about computers, languages, and dialects, because this is something that's already come up. So here's an example from China. So in China, there are a very large number of language variants. Who here is from China? So does everybody speak Chinese in the same way? You're shaking your head, but you're from Shanghai.
Well, I sometimes not understand my
Uh-huh.
you must speak
So there are a lot of different language varieties in China. There's Standard Mandarin, or Putonghua, that is the standard language of China. That serves as the basis of both the written and spoken standard. But there are also other varieties of Mandarin that are spoken in northeast China and that are different in various ways from Putonghua. Sometimes to the extent that it's hard to understand, it's hard for a speaker of Putonghua to understand these varieties. There's also Shanghainese and other Wu varieties of Chinese. Very different from Putonghua. You know, so kind of in speech, can a person from Beijing understand a Shanghainese speaker? They- they-
I can do examples if you want. Like people around me can do that.
uh-huh.
아즈모와 다들.
Yeah, that does sound like Japanese. So there's Shanghainese, other Wu varieties. There's Cantonese and other Yue varieties. There's Hokkien and other Min varieties. And then there are other groups of varieties like Jin, Gan, and Shang that are spoken in different parts of China. So there are all of these varieties. Now, these don't show up so much in writing, except there's a writing system for Standard Mandarin, and there's a writing system for Cantonese. Cantonese can be written with a different set of characters, it has words, a lot of words that Standard Mandarin doesn't have, and there are old characters for representing these words that go back before the standardization of Standard Chinese. So I have a friend who worked for a number of years at Apple writing input methods for Cantonese so that people could enter Cantonese characters on their iPhones and iPads and with their laptops. But for these other languages, they're basically not written anymore. They were at various periods of time, but now everybody just writes in Standard Mandarin. And even though these languages have different grammar and different words than Standard Mandarin, people just do that. And it's kind of not outside of the bounds of Chinese history, because prior to the standardization of Mandarin, then a lot of people just wrote in classical Chinese. It was basically like writing in Latin. And everybody was at an equal disadvantage because they're writing a language that was that had not been spoken for 2,000, 3,000 years. It kind of looks in writing like these languages are all pretty much the same, like these varieties are all pretty much the same. And in fact, Chinese speakers, both linguists and lay people, refer to these varieties as Fangyan. And this is conventionally translated into English as dialect. But it means something different from what the English word dialect means when it's used by linguists. For linguists, a dialect is a language variety that belongs to a set of mutually intelligible varieties. So these Fangyans are written with the same script and are descended from a common ancestor, but they're often not mutually intelligible. That means that if you put someone from Shanghai and someone from Beijing together in a room, then they can't understand each other, except that the person from Shanghai learned Putonghua in like grammar school. Otherwise they would not be able to understand one another. They're not mutually intelligible. So what is the best English translation of Fangyan in this context? So Fangyan are, to use the terms linguists would use, they're separate languages. Now, this is a little bit oversimplifying, because people would also consider varieties of Mandarin to be Fangyan, and they're not really separate languages because they're mutually intelligible with one another and with Putonghua. So they're not necessarily mutually intelligible. They have different phonology, different morphosyntax, different lexicon, different lexical semantics. And in many cases, it's not possible to use the same language technologies for all or even a large subset of these language varieties. But people use them every day in their everyday lives, in their day-to-day lives. The Chinese state has expended a lot of resources promoting Putonghua in the interest of national unity and other goals. But it looks like people are going to continue using these other varieties in their day-to-day lives when they're not at school or at work. Is that your impression about Shanghainese, or do you think it's going to go away?
I don't think that many users promote people. I think the opposite way is that they turn users to promote the
Are they?
yeah, because in the past the schools would teach you how to speak Chinese.
Uh-huh.
Now it's not, and also like in these elementary schools,
Uh-huh.
teachers will ask to like locate active speech because they speak to the all the way around. But I want to bad elementary school
Well, certainly the Chinese government encourages education, a lot of levels in standard Chinese. And this includes not just Han Chinese people, the major ethnic group of China, but also minority nationalities as well. There's a lot of effort made to make sure that they can speak standard Chinese. It's a complicated picture, but I don't think that these languages are going away. So we might want to support them in language technologies. We might, for example, want to have speech synthesis and speech recognition in Shanghainese. Why would we want to do that? Why not just, everybody in China below a certain age can kind of speak Putonghua anyway. So why not just rely on Putonghua for our virtual assistants and other things that might use speech? Yeah, people like to talk, in their first language, and so there's going to be a market for people, for language technologies. This is already the case for Cantonese and Yue. That there are people who develop language technologies because people like to speak these languages. They feel more comfortable talking to somebody. They feel a greater rapport with a machine that speaks their language than one that speaks the standard language. So this is not an issue that's unique to China. In Arabic, there are a lot of different varieties that are referred to conventionally as dialects. So you have Egyptian Arabic and Maghrebi Arabic and Lebanese, Levantine Arabic and Iraqi Arabic and Sudani Arabic. These speakers of these languages actually can't understand one another. They're not mutually intelligible. They're really separate languages, but they use a shared writing system and have a shared history. And so people treat them as dialects of a language. But from the standpoint of what you would need to do to develop language technologies for them, they are separate languages. So India is somewhat different. India has a lot of minority languages which are sometimes, which are conventionally called dialects. These are usually not mutually intelligible with regional or dominant languages, but often they're just completely unrelated. So the convention is to refer to tribal or minority languages as dialects and big languages as languages. Like if you're one of the scheduled languages of India, you get to be a language, and otherwise you're a dialect. But for these varieties, you need totally different language technologies if you're going to support them. So we know a number of people and organizations who are interested in developing assistance for language technologies for low resource languages. And if you're interested in working in this area as part of directed research or other opportunities, then please let us know and we'll try to hook you up. It's also, oh, this is for fall, but there's a graduate seminar on endangered languages, which is typically taught in the fall by LTI faculty. And in this seminar, then students learn about language endangerment and how technology can help with language revitalization, relating to speech and language technologies. Also in the fall, there's a course taught called Human Language for AI, which is an introduction to linguistics for computer science students. And you can learn about the structure of human language at all levels of abstraction. It's strongly multilingual in its emphasis. But there should be, oh, it's missing. So there's also a course that's kind of interesting that you could sign up for this spring if you're interested in languages and making languages, and that is conlanging. So this sounds like a frivolous kind of course because, the kind of people, who make up languages are these sort of sci-fi or fantasy nerds who, but this is actually a serious linguistics and NLP course where people learn about the structure of language and language technologies through designing a language. So if that sounds interesting to you, and I think it might be interesting to some of you, please look in the course catalog and sign up. It fulfills requirements. Have you taken that?
Oh yeah, I took it with my favorite class.
Yeah.
Yeah, I love it.
Yeah, that's what it's called.
It was awesome. It's very much not like we're going to teach you Elven and Quinoa. It's just more like develop your own language. But I learned more in it than I have when I had courses about like practical research.
Uh-huh. So there you go. Take conlanging. So Professor Black teaches that along with Lori Levin, and I think it's a good course. I'm running out of power somehow on my laptop, so I may get cut short. Let's see how much I have left. I've got 5%. Oh. Does anybody have? I need USB-C. Does anybody have an adapter with USB-C? Sorry about that. I don't know where my battery went. Okay, let's talk the last little bit about Google Translate and about multilingual language technologies. So humans, when you compare them with machines, with machine learning, have certain advantages and certain disadvantages. So if you're developing language technologies as a human, say you're developing, you're writing a rule-based NLP system versus training a machine learning-based system on data. What are the advantages that the human has, and what are the advantages that the machine learning has? Let's start off with the human. What advantages does a human have in developing some kind of NLP system? Yes. Uh-huh. So humans have language competence, right? They can make judgments about what is grammatical or what is ungrammatical in a way that it's hard for a machine to do. Hard for a machine learning. The what? Well, they can sometimes capture that sort of thing. You know, a machine learning model, given enough data, can do things that kind of correspond uh, to intuitions. But let's say you're writing a grammar versus training a grammar using machine learning. What advantages do you have? Yes. So you can have domain knowledge, and you can apply this knowledge of the domain to the specific thing that you're doing, like knowing about how languages function in general can allow you to, you can apply that knowledge and um, use it to write your particular grammar. Um, yeah, and you really, you know, as a human, like a trained linguist can really understand the structure of language and how languages are different from one another. And they can also write very precise rules, which can be a great advantage if you're trying to, say, develop a grammar that distinguishes between what is grammatical and ungrammatical. Like if you're writing a grammar for grammar checking. What is bad about humans? This should be easy. You're all computer scientists. You don't like humans. Uh-huh. Yeah, so you have to, it's really hard to train humans to behave the same. And it's really hard to have a single human build a whole grammar. But it's really, you know, there's really a problem. There are two kinds of problems. One is that, you know, humans are not very quick at doing this sort of thing. It's slow, and it's error prone because of the coordination problem. So humans also, there's a limitation in that if you want a human to write a grammar, the human sort of has to know the language. Or they at least have to know so much about the language that they can write a competent grammar. And it's really hard to do that without actually knowing the language. So in order to get a linguist to write a grammar for you, you have to find a linguist who knows the language that you want to write the grammar for. And it's hard to find people that have the skills that are necessary to do this. So humans have a lot of disadvantages. They have some significant advantages, but they have a lot of disadvantages. Well, what about machine learning? What are the pros of machine learning? Why do we do so many things with machine learning now instead of with hand-engineered rules? Okay, because it's cheaper. Why is it cheaper? It's what? We don't need the humans. We don't need to pay the humans. Um, or we don't need as expensive of humans. We might be able to get away with mechanical Turkers if tasks are menial enough. So, the big, separate from the kind of data that like Turkers might provide, nobody needs to know the language. The model doesn't need to know, ostensibly, doesn't need to know anything about the language. Language data is just data. It's fast. Once you have your data, you just train your model, done. And it's also graceful, robust. So if you come across something you haven't seen before, the model is statistical, and it's going to handle it, take everything in stride, basically. It's not going to collapse in a heap of rubble when it comes across something that was not foreseen by some human engineer. Well, what limitations does machine learning have in the domain of NLP? Yes.
We need lots of verbal data, and for most languages, we just don't have.
Right. So that's something that my research has concerned a lot. Is the fact that we often want to do work on languages or domains that have limited labeled data, and in order to train most machine learning models, we need labeled data. And so sometimes you have to do something that's sort of a hybrid approach, where you can have rules that help the machine learning along. Yes? Yeah, so machine learning algorithms often produce sort of cute results. So sometimes they're uncannily good. Often, like with neural models, if you've noticed, like neural machine translation is really good with regard to fluency, but neural models often hallucinate things. And so, like for machine translation, they'll just come up with things out of nowhere. So there'll be words or phrases that were not in the original, and everything sort of fits together in syntactically correct English or whatever the language is. But it doesn't really make sense, or it doesn't really say what the original said. So they say weird things. They make strange mistakes that are hard to understand. Hard to fix, actually, because you don't necessarily know where the strange mistakes are coming from. So there's the promise and there's the reality. The promise of machine learning is that nobody needs to know the language. Techniques are language independent, and specially trained humans are not required. They're fast and they're robust. But the reality is that the techniques do not work equally well for all languages. This is true of most NLP technologies that are based in machine learning of any kind, that they don't work equally well for every language because of a variety of things. It can be because of the structure of the language. It can be because of the structure of the data in a particular language. But it's also true that although it can be fast to deploy a machine learning model, it's also, and you can come up with the first version quickly, often. It often takes a lot of time and a lot of tweaking and a lot of energy to refine their performance up to the level that they currently have reached for languages like English and Chinese and Arabic. So there's a lot of tweaking that has gone into them getting as good as they are in these languages. And there are certain kind of basic constructions that a lot of machine learning models have had difficulty with. One is with relative clauses. So these are clauses that modify nouns. So the wallet I lost, or they tend to get mixed up whether the relative clause has what's called a subject gap or an object gap. So and even BERT doesn't always get the structure of these things right. Even models, models based on the newest transformer-based architectures don't always do this right. So let's compare. This is actually a happy story. It's a story of Google Translate getting better. So this is what Google Translate did on April 4th, 2016. If you gave it this original, the Supreme Court ruled unanimously that states may count all residents in drawing election districts whether or not they are eligible to vote. When you asked it to translate to Arabic and then back again, then it said, the Supreme Court ruled unanimously that the roll may count all residents in drawing electoral districts whether or not eligible to vote. It's got some disfluencies and it's got some things that don't make sense, like the roll instead of states. Some things that are just incorrect. It's okay. The Chinese says Supreme Court unanimous, so we've got a disfluency right here at the beginning. Unanimously ruled that the state could not expect all residents in drawing the selection regardless of whether they are eligible to vote. Okay, so not so good. So it has both disfluencies and inaccuracies. Well, let's go forward in time to May 1st, 2017. Here we have the Supreme Court ruled unanimously that states may count all oh, actually, I should go back. Which is better, Arabic or Chinese? Arabic. In fact, this is systematically the case for these kinds of models, that Arabic scores better, gets better blue scores than Chinese. When you're translating from English. Why would this be? Oh, we're at time. Okay. It's an interesting question to which nobody can really agree, but a lot of the issue may have to do with the fact that Chinese, although superficially it looks structurally like English, is actually, when you look at actual text in Chinese, it's actually very different than what you would have in English. The structure, rather than being based around like subject and object, there's not really a notion of subject. There's instead a notion of like topic and comment, and just the rationale around which the sentences are structured is different, and it's harder to. And there's also the issue, and it's just harder for the model to make sense of all of that. Where Arabic, although it looks different from English, has a lot in common with English structurally at a deep level. And so there's structural divergences that favor Arabic over Chinese. Anyway, take care. Good luck on your projects. And I will see you later.